Okay, so now let's go ahead and do our color contrast calculation. And the first thing I want to do is, so this one I want to do after I've set the styles, because this is an element node. And then instead of just logging them, what I'm going to do is call a check function. So check contrast. And I'll fill that in a second. Let's start with our logging message. And then we need we will need the tag, and we'll need the foreground color and the background color and the size and the weight. And let's go ahead and pass the text in too, because it's tag.nodeValue for text nodes and tag.label for element nodes. So this is going to be text here. And then let's call that. And we'll pass in tag and tag.nodeValue. And for back, size, and weight. And then here we'll do the same thing, except we'll pass in tag.label. Let's go ahead and make sure it still works. Looks good so far. All right, so let's look at the calculation. So the first thing, let's go ahead and calculate the color contrast first. So this part's easy, but right now we have a color string, which is this thing right here. And we need to get an R value, G value, and a B value from that. So let's do that first. Let's define a function, color values, and it'll take a color string. And then what we want to do is return an array of values. So, and we'll need a values variable. And so what we want to do is we want to strip out just this part of the string. So that's going to be the 0, 1, 2, 3, 4, and then the number of characters is the length of this whole string minus 4 plus 1, which is 5. So I can use substring to do that. So our value string is equal to color.substr from 4 to color.length minus 5. And this is if it's an RGBA string. So if color.index of RGBA open paren is equal to 0, then we'll return that. We'll set that. Else, if color.index of RGBA is equal 0, then we have one additional character. So this would start at position 5, and length minus 6, else, well, let's just make it 0, 0, 0, since the default color is black. So that gives us our value string, which is going to be number, comma, number, comma, number. And then let's set value array equal to value string dot split on comma. So that's going to give us an array of 0, 0, and 0 in the 3 elements of the array. And then values is going to be value array dot map. And then we want to run a function on each element of the array. And it's going to return parse float of elements. So if we have 3 values in our array, we'll have an array of 3 values coming out that are the floating point values for each element. And here, let's set for_color equal to color values of 4, and that color is color values of that. And then here, instead of outputting 4, we'll output for color. And here we'll output that color, just to make sure it looks like everything is working. So I'll reload and run it. Okay, so we have an error. So we must have a syntax error. We must be missing a curly bracket or a double quote somewhere. Yeah, we need to close this off. So we closed off our function, but we also need to close off our map. So close the function, close the map, and now let's try it. Okay, so values is an array of 0, 0, 0. Value string is the string 0, 0, 0. And our color is RGB 0, 0, 0. So everything looks like it's working. Continue. Okay, now index of. So what do we have for color here? So let's go ahead and look at color. So color is undefined here. And back is undefined and 4 is undefined. So we need to be able to handle an undefined value as well. So let's go ahead and make sure that we don't have an undefined color. So we're going to pass in a default and check colors. And if 4 is undefined, 4 is equal to RGB, black text is the default, and if back is undefined, passive white. So black text on a white background is the default. And now let's go ahead and reload it and run it. Get rid of the breakpoint and continue. So console. Good. So it looks like we have the right numbers here. Yep, we have foreground and background color. And now we can do our calculation of contrast. So let me juggle windows a little so I can see both of these things. Let's do it this way. So we need to calculate a luminance value for the foreground and the background color. So let's create a function luminance, and that's going to take a color value array. And then we'll call L1 is equal luminance of forecolor, and L2 is luminance of back color. And then first thing we need is R is color sub 0, the red component, over 255. And G is color 1 over 255. And blue, color sub 2. So those are SR, SG, and SB. And then we want to have this thing here, and this is the same function for all three color components. Now this thing is basically it's adjusting for brightness and contrast. So we're going to create call that component value of component, and if component is less than or equal to 0.03928, then return component over 12.92. Else return and then component plus 0.055 and then divided by 1.055 and then raise that math.power to 2.4, and that's adjusting for the gamma of the display. Basically magic. So that gives us our SR, SG, and SB. And then the luminance is 0.2126 times component value of R plus 0.7152 times component value of green plus 0.0722 times component value of blue. So these constants, basically, they deal with the fact that the eye is more sensitive to certain colors than others. So green is the color that we are most sensitive to, and then blue is the color we're least sensitive to. So in terms of providing contrast between bright and dark, the brightest blue is still pretty dark, whereas bright green is pretty bright. So the overall luminance of the color reflects that. So now we have luminance for foreground and background. And then this part of the formula here, let's move it over a little. So basically, measure the relative luminance of the background pixels. So L1 is the relative luminance of the lighter of the foreground or background colors, and L2 is the darker of the colors. So basically, if L1 is less bright than L2, we need to swap them. So if L1 less than L2, then temp is L1, and L1 is L2, L2 is temp. So we've swapped them, and then contrast ratio. So now we're ready to calculate our contrast ratio. And that's going to be equal to L1 plus 0.05 divided by L2 plus 0.05. So let's put that right up front, contrast colon, and then we'll do contrast ratio dot to fixed 1, because we only want one decimal point here. And let's go ahead and break this line again. So now we should be able to look at our contrast ratios. So reload and check. Okay, got a little error. Oh, so missing a parenthesis here. So that balances that, that balances that. We need one more for the power. Actually, we can just get rid of that one. So right here, okay, so 21.0, we need a space and a comma here. Let's go ahead and fix that. Comma space. Great. So 21 to 1 is the best possible contrast. It's black text on a white background. And then red, green, blue. So this is blue text on a black background is 11.2. And 7.7, this is a gray text on light background, dark text on light background. So the word top, let's see top. So this button here, that's dark text on a slightly bluish gray. And let's start at the top here. So this 7.1, techniques for WCAG 2.0, that's purplish blue text on a white background, and that's 7.1. So not surprisingly, all the contrast ratios look pretty good on the Web Content Accessibility Guidelines page. Let's go ahead and implement our rule for, well, let's start to implement our rule. So we're going to go back here, and now that we have our contrast ratio, so if contrast ratio is greater than or equal to 4.5, then we're going to skip this, because everything is okay. else if, and now we need to get the size as a number. So size, so parse float size is greater than or equal to 18 point font, and return. So anything that's 18 or greater is considered large text, and if it's large and contrast ratio is greater than or equal to 3.0, then it's good. So large text with greater than 3.0 is good. Then the next one we have to do if it's greater than or equal to 14 and bold, and contrast ratio is greater than or equal to 3.0. So we need to get this bold here, and I'm going to need the size again, so let me go ahead and do that. Let's call that size string, and we'll add size, parse float of size string. And then I need a function isBold. So let's go ahead and do isBold next. Well, if size greater than or equal to 14 and contrast ratio greater than or equal to 3.0 and is bold weight, then return. So let's do is bold. So the easy one is if weight is equal to bold for Chrome, return true. If weight equal normal, return false. Otherwise, I need to know if it's a number or not. So let's go ahead and call this weight string. And we'll create a variable for weight. And I'm going to put this in try, catch error. And weight is equal to parse float weight string if weight is greater than or equal to 700, return true, else return false. So we try parsing the weight string. If it starts with a number and that number is greater than or equal to 700 for Internet Explorer, that's bold. Otherwise, if we get a number and it's not greater than or equal to 700, then it's normal. And if we get an error, we'll assume it's normal fonts. So there's our isBold function. So this should be all the conditions, greater than 4.5, or it's large text and contrast ratio 3.0. So let's go ahead and try it on the accessibility page, and we get nothing. Right? No accessibility errors found. Let's try it here. Either that or our code didn't work. Let's try it on the PCC homepage. Oh, we got some. So let's see what we got. Well, some of these are empty text, and so those aren't really accessibility issues because they're not going to affect a student with a visual impairment. So let's check for that. So the first thing we want to do is call the trim function, and if trim is equal to nothing, then we don't have to worry about accessibility. Okay, so we still have some issues. Let's see. So this skip to page content, that's actually, I browsed through this page before, so. Right there, skip to page content. But if I click on this, you'll see that the left is set to minus 10,000, and width is 1 pixel, height is 1 pixel, and overflow is set to hidden. So even though this exists, it's not really visible. So let's also go ahead and ignore anything where the width or the height are less than a certain threshold. So what I'm going to do here is I need to get the bounding box for this tag. And the way you do that is bounds is equal to tag dot get bounding client rect. I think that's right. Let's actually try it here. So the ID for this is skip nav, so let's go here and let's var anchor is document get element by ID skip, is it skip under nav? Nope, just skip nav. So here's the problem. Here's the one we're having an issue with. And then get bounding client rect. So we get width and height, but only in certain browsers. So I think the modern ones pretty much all have width and height. But some of the older ones, they just have left, bottom, right, and top. So we're not going to rely on width and height to be set here. So if bounds dot right minus bounds dot left is less than 2 pixels, return. If bounds dot bottom minus bounds dot top less than 2 pixels, return. And then we can check whether it's off screen as well. Bounds dot left, sorry, bounds dot right is less than 0, return. And if bounds dot bottom is less than 0, return. So these are both if it's off screen. Get bounding client rect. What was it? Get bounding client rect. So let's go ahead and try it. Tag. Probably have a typo. So text tags don't have it. Get bounding client rect. Right. So I have to check the parent. That will work. Okay. So if tag.getBoundingClientRect is defined, then I call it on the tag, else I call it on the parent. Okay, so fewer stuff coming back. Let's see what we have. So we have this bar right here, and then more top stories. It's right there. And then to kickstart your career or four-year degree, so these texts in a year and so on, so all those texts with high school completion, and by supporting the PCC Foundation. So it looks like we flagged all of the right things. And in the next video, we'll actually add some warning tags to the HTML.